We're now going to talk about something called polynomial long division. So it's very similar to regular long division. So along those lines, let's go ahead and take a look at what we'd learned as long division in the past. So let's say we had 1,247 that we want to divide by 7. So quick review of this. 7 can't go into 1, so we go to our next chunk. 7 can go into 12 one time. So 1 times 7 is 7, and then we subtract it out. So 12 minus 7 is a 5. Bring the next number down, 4. 7 goes into 54 7 times. 7 times 7 is a 49. We subtract it out. We get left with a 5. We bring the next number down, which is 7. 7 goes into 57 8 times. 8 times 7 is a 56. That's 1 left. So if we were to write this number, this answer is 178, and then the remainder is 1 over 7. Okay. If we did this on the calculator, 1,247 divided by 7 is 178.14, which is approximately the same answer here. Okay. So we want to use those same ideas here for something called polynomial long division. So for example, if they asked us, let's take x squared minus 7x minus 11, there's a polynomial, and that's a trinomial, 3 terms, and we divide it by x minus 8. So it doesn't look like long division just yet. What we're going to do is reform it into a long division problem. Put the bigger piece inside, x squared minus 7x minus 11, the smaller piece outside. So I'm dividing the binomial into the trinomial. Now I like to leave this outside one in parentheses because I want to remember that as one chunk. So the name of the game is I want to get as close as I can or match what I have outside to what I want inside. Now we never put anything in this first blank here. So let's move to the next one. So bear with me. I have x right here. My first term is x. I want to make an x squared. So x times what would give me x squared? That answer would be x, and that goes in this blank. So I'm going to take that and multiply it here. So x times x is x squared. But I also have a second term over here, and I need to multiply as well. X times negative 8 is a negative 8x. All right. Now if we think back to this here, once I did the multiplying, I wrote that 7, but then I subtracted. I have to do the same thing here on my polynomial long division. I did the multiplying, but now I need to subtract. Now technically this whole thing is a chunk, and I need to subtract it. So what that shows it as is really this negative sign needs to get applied to both. So negative here, and then this sign flips to a positive, and we'll sum it up. If your first terms don't cancel or disappear, then you did something wrong. So let's see, x squared minus x squared, those cancel. That's what we're trying to do. We're trying to cancel them. Trying to get rid of terms. The next one's a negative 7x and a positive 8x. That is a 1x. That's fine. And now we bring down the next term, negative 11, and now we continue. I have x. I need to make 1x. I need to multiply by something to get there. The thing I'm going to multiply is a 1, and in this case, a positive 1. So 1 times x is x. 1 times negative 8 is negative 8. And then here, I need to make it subtraction. I need to subtract them. I need to flip all the signs. So we go like that, and we sum it up. If your first terms don't cancel, you've done something wrong. X minus x do cancel. Negative 11 plus 8 is a negative 3, and we have no more terms to bring down. So let's see how we write this as an answer. This is the part that divided in nicely. This is the remainder. This was the original. So let's put this all together. So as an answer, we're going to take the part that divided nicely, x plus 1. The other part is negative 3 is my answer. And then on the bottom, as a fraction, x minus 8. Now, what I'm going to do is I'm going to float this thing here, make that the negative sign, so it's x plus 1 minus 3 over x minus 8. So that's just a proper way of writing that. If not, then we would just leave that as a plus sign. But for right now, that is my final answer. That is what I get when I divide it out. Let's try another one. Practice makes perfect. For example, x squared plus 14x plus 38 divided by x plus 8. So bigger piece inside. Smaller piece outside. I like to group that one. Let's go ahead and go for it. I need to make x squared. I only have x, so I'm going to multiply by an x. X times x is x squared. X times 8 is 8x. Flip all the signs because we're subtracting it now. Sum it up. The first ones have to cancel. 14x minus 8x is a 6x. Bring down the next term, plus 38. All right, let's do the process again. I have x, I need to get to 6x this time. So I'm going to multiply by a positive 6 because I want to match it right now. I'll flip the signs in a second. 6 times x is 6x. 6 times 8 is a 48. And now I flip the signs. Negative, negative, sum it up. First terms cancel. 38 minus 48 is a negative 10. And now we have all the info we need to write our answer. Let's write this out. X plus 6 minus 10, and then I can kind of move that minus sign to right here over x plus 8. Okay, remember that negative sign goes with that 10, so I can float it in front or with it. It just looks better to float it right there. And there we go as our answer. All right. Five m squared minus 12m plus 3 divided by m minus 2. Okay. So bigger piece. This time the letters are different, but it really doesn't change the process. I have m. I need to make 5m squared. So I need to multiply by 5m. So let's look at that. 5m times m gives me 5m squared. Good, I want to match it at first. 5m times negative 2 is a negative 10m. Once I do that, now I flip the signs. Sum it up. First terms cancel. Positive 5m squared and negative 5m squared cancel. Negative 12m plus 10m is a negative 2m. Bring down the next term, plus 3. And let's do it again. I have m. I need to get to negative 2m. I'm going to multiply by a negative 2. Negative 2 times m is a negative 2m. Negative 2 times negative 2 is a positive 4. Now I flip the signs. So that becomes positive. This becomes negative. Those cancel. 3 minus 4 is a negative 1. And I have all the info I need to write my full answer. So I've got 5m minus 2 minus this 1 over m minus 2. Okay, remember that negative sign goes with the 1. Sometimes it's positive. I don't think we've seen positive just yet. All right. So let's just up the difficulty for these last couple ones. $50x³ plus 10x² minus 35x minus 7. So this time we've got a 4-piece polynomial divided by 5x minus 4. So it's just adding one more step to our problem, but we still write the bigger piece inside. Bigger or smaller piece outside. Just add one more step because of the extra term. I have 5x. I need to make 50x². So if we're going from 5 to 50, I need to multiply by 10. To go from x to x² or x³, I need to multiply by x². So let's trace it out. 10 times 5 is 50. x² times x is x³. And then to the second one, negative 4 times 10 is a negative 40 x². Now I flip the signs. Negative, positive. These cancel. If they don't, something's wrong. 10x² plus 40x² is a 50x². Bring down the next term. Minus 35x. Alright, let's do it again. I have 5x. I need to get to 50x². That's going to be multiplied by 10x. That gives me a 50x². 10 times negative 4 is a negative 40x. Now flip the signs. Those cancel. That's good. Negative 35, positive 40 is a positive 5x. Bring the last term down. Minus 7. And look at that. I have 5x. I need to get 5x. I still need to multiply by something, and that something is a 1. 1 times that negative 4 is a negative 4. And now I flip all the signs. Negative, positive. Those cancel. Negative 7 and positive 4 make a negative 3. And I have everything I need to write my answer. I'll write it over here. So 10x² plus 10x plus 1 minus the 3 over 5x minus 4. All right. One last one, because you'll want to see what happens here. Let's say we have 20x to the 4th minus 5x² plus 18 divided by x minus 6. Now what I want you to notice here is the exponents. We got x to the 4th, x², and then no exponents. Exponents are missing. You notice there's no x³, there's no regular x to the 1. You still need to write those terms in. Okay, so we're not going to actually finish this problem. I just want you to make a note of it. If any terms are missing, we're going to use zeros as their placeholders. Zeros in their place. And I'll show you how to write that. Okay. So that's my original problem. That's fine. I can start with 20x to the 4. I don't have an x³, so I'm going to write plus 0x³. I do have an x², so I'll write that. I don't have a regular x, so I'm going to write a plus 0x. And I do have the 18 at the end. Okay, so anytime I'm missing something, I need to fill it in with the placeholder here, and I'll highlight those placeholders. because we would still do the problem as normal. And I guess I can get it started for you. I won't finish it off. I have x, I need to get to 20x to the 4. I would multiply by 20x cubed. Okay, so that gives me 20x to the 4 minus 180x cubed. Flip all the signs, minus plus, those cancel, and now we just sum it up like it's a 0. So 0 plus 180 gives me 180x cubed. Okay, and then bring the next thing down. So we still need that place in there. If we don't write it, the answer is not going to come out correctly. So anytime I'm missing terms, make sure you have a placeholder of a 0 in there, and you can still write the letter next to it. All right, so the big thing to remember today is it's very similar to our original kind of long division problems, and then just understand how to write those answers out with the remainder, with the original division parts. But otherwise, everything's pretty good.